Hello again everyone, welcome back to ptet.chemistry channel. So my name is Mr. On, and in this tutorial video I'll go through this atomic structure, which is book 1 for for the class that I'm teaching, which is the students who are going to sit for the 2023-5070. This is the chemistry O level for the Cambridge International Exam. This is equivalent to GCSE or IGCSE chemistry curriculum. Whether you're doing a core or extended paper, atomic structure is an important topic regardless. So in this question, we have these terms that we have to classify a few substances: elements, compound, and mixtures. And we know that elements can be further divided into metals and non-metals. These are elements that you can find in the periodic table, and the metals tend to be found on the far left of the periodic table. And of course you also have the transition metals, which from the name itself, they are transition metals, they are transition elements, they are all metals. And the non-metals are usually on the far right of the periodic table. So these are just a bit of generalization, and they are not necessarily like, you know, word by word whatever it always is. Okay, it's just a general idea. In terms of definition, so any chemistry student should be able to tell you a little bit about the definition for each element. So any chemistry student who fails to do this means that you don't really understand chemistry at all. Okay, so an element is a substance that you cannot break down into any simpler substances by chemical method. That's because they only contain one type of atom. Okay, so an element is a substance containing only one type of atom. So there's only one kind or one type of atom, only one type of one kind, and it cannot be broken down, into simpler substances by chemical method. So chemical method is usually quite a harsh method, requiring a large amount of energy to transform from one form to another. And if you can't do it even by chemical method, that means it's impossible to actually do it, at least in chemistry. Okay, so a compound, on the other hand, a compound consists of two or more atoms chemically combined together. It's a substance that contain, or you can say consists of, two or more elements which are chemically combined together. And what is important is that for a compound, they're chemically combined in a fixed ratio. That's why when we have a formula of a particular compound, that exists as like how many atoms of this particular element and how many atoms of the other element. Okay, so because of the 2 marks for each of these, it's important for us to specify as much information as possible. So these are further characteristics of a compound, chemically combined in a fixed ratio. And you can of course also talk about the properties of compounds being very different from its constituent elements, or from the elements that are used to make up the compound, right? So for the 1 mark for mixture, so mixture is made up of, or you can say consists of, is the same thing, consists of 2 or more substances. Why do we use the term substances now and not elements? Because you can have element plus a compound, or you can have element and element, different element combined together, mixed together, or you can have different compounds mixed together. Okay, so it can be elements and or compounds. So it doesn't matter how you mix them together, it's still going to be a mixture, right? Mixed together. So it's just mixed, they are not chemically combined. Okay, so hence, because they are not chemically combined, the ratio of these substances is not fixed. Okay, is not fixed, or you can say it's not defined. It's not a fixed number, it's not a defined number. Okay, so the components can also be separated easily as well. So we need to classify each of the following substance as either an element, compound, or mixture. So brass is an alloy. The definition of an alloy is a mixture of metal, and brass is made out of copper and zinc, if I'm not mistaken. And because it's a mixture of metal, very clearly is a mixture. Okay, carbon dioxide has a proper formula, CO2. I'm sure if you read the news or whatever, you will have heard that there's an increase in the amount of CO2 in the atmosphere that results in global warming and uncertain weather patterns all around the world. And this has a fixed ratio of carbon is to oxygen, 1 carbon and 2 oxygen, and this is a compound because it consists of 2 elements, 2 or more elements chemically combined together. Copper is a metal and is a metal in the transition element block, and transition element is also the transition metal. So it is a metal, and when it is a metal, it is an element, okay, because you cannot break it down further into simpler substances. And you can also find copper as element number 65, if I'm not mistaken. Let me have a look at my periodic table. Copper is element number 64, okay, in the periodic table. So in this question, we have a chromatogram. They are obtained from 4 different mixture of dyes, and we use water as the solvent. There is the substance that dissolve all 4 different kind of dyes. So we have P, Q, R, and S. As you could see vertically, P is impure, is separated into 3 dots. Q is also impure, is separated into 2 dots. R is impure, separate into, well, R is actually pure, it's separate into 1 dot only. And S is impure because it's separate into 2 dots, alright? Well, actually R is also impure because it only separates into 1 dot, but you still have another substance which does not move at all, alright? So this thing does not move at all, so that is a result of it being insoluble in the solvent. What was the solvent we used? Remember that we read the question earlier, and we circle and we read the question earlier. We use water as the solvent, alright? So just because you see 1 dot, but you also need to consider that do you have any other dots that are left at the starting point, alright? So the baseline and the solvent front, which you need to take out the filter paper, the chromatogram, before the solvent, in this case water, before the solvent is allowed to reach the very top of the chromatogram, you have to take it out and mark it with a pencil as well, where the solvent end up moving. Your water level, meaning in this case your solvent level, must be below the baseline when this is put into the solvent. So explain why the baseline is drawn using a pencil rather than an ink. So, well, an ink pen is a mixture, whereas a pencil is made of graphite, which is a pure substance. A pure substance. So mixture will separate in this technique as well, but not the one that are drawn by pencil, which are made of graphite, and it will not separate into different substances at all, okay, because it's only one pure substance. Identify the mixture that contains a dye that is insoluble in water and give a reason, alright? So here they're very kind to provide you what is the mixture and what is the reason. Otherwise, you have to remember to address and also answer every single bit of the question. So out of the 4 different dyes, R is the one that contains a dye which is insoluble in water, the solvent used in this experiment. That's why it does not move at all. It stays at the baseline. Alright, so that mixture has to be R. The reason is it has a spot that remains at the baseline. So the baseline spelling, in fact, it was labeled for you if you read the question carefully. That remains at the baseline, i.e. it is insoluble in the solvent, and the solvent was water. Therefore, it does not move up at all. Or you can say it does not move at all, it does not travel at all up the chromatogram because it is insoluble in water, somewhere along that explanations, yeah? State the number of mixtures that contain two different dyes. So be very careful. You're looking for something that will separate into two different spots that have moved, including, well, it's actually difficult to say it contains two different dyes here because this could contain, well, it says it contains a dye, alright? It contains a dye that is insoluble in water. So this is 1 and this is 2. So there are two components here. A dye and this one that is soluble in water. So this one moved. So this is 2 component. This is also 2 component. This is also 2 component. This has 3 component. So in terms of 2 component, we're looking at Q, R, and S. That means there are 3 different dyes that separate into 2 components. Alright, so there are 3 different mixtures, and these include R, which has 1 component, 1 particular dye that is insoluble in water, and then another one. So there are 2 components in this mixture as well. So then use the figure to determine the total number of different dyes that are present in all 4. Alright, so here we need to look at what is different. Okay, so I'm gonna circle pink one. This is definitely different, 1. And then you have this one at present the same level, and then you have a different one. This is also present the same level. So meaning to say we have 1, we have 2, and then we have 3, we have 4, and we have 5. Oops, sorry, I forgot that there's 1 there. So we have 5, and then we also have 6. Alright, so this is the one that doesn't move, is one of the dye. These all have the same horizontal spots at the same level, so they travel up the same solubility in the solvent, the same substance, so they separate into the same spot horizontally. Okay, so this is only one spot considered. This is another substance. These 2 spots overlap at the same horizontal level again. They both travel up the same distance from the baseline. So these 2 are the same substance. It's just considered as one substance. So 1, 2, 3, 4, 5, 6. So altogether, there are 6 different dyes present in all the 4 mixtures. So that's the end of this chromatography work 1, and there will be a separate video to cover the rest of the work when we have finished filtration, crystallization, and distillation as well. So hopefully that was useful, and just ask me anytime I'm in school, or text me or email me if you got any questions.